Good afternoon. I am KSV Fanendra and I am part of the project Solenoid Engine, which we have been doing for the past 1 month for our industry-oriented mini project lab. The name of our project is Solenoid Engine and the batch members are Akiruthik, KSV Fanendra, NV Dharmateja. This is the abstract of the project, which is when the electrical energy is converted into rotational energy with the help of solenoids. These work under Faraday's laws of electromagnetic induction. This variant will have 8 coils with pistons inside them, providing the rotary motion into the reciprocating motion and provides power to the flywheel. These are the list of the parts which we have been using in our mini project. Engine block, piston, L brackets, flywheel, crank webs, camshaft, gas, solenoids, bolts, nuts and screws and washers, grub screws, connecting rods, dimmer, rectifier, MCB, bushes. These which you have been seeing in this picture is a solenoid. These solenoids are nothing but copper coils wound around a hollow aluminum tube. The ends of the tube are welded with mild steel plates. When current passes through the coil, a magnetic field is generated which pulls the piston upwards, and this motion is reciprocatory motion which continues. Wire of gauge length 23 mm has been used, and around 1500 revolutions of wire has been put to the solenoids. The material which we have used for the hollow aluminum tube and the rest of the base is made up of mild steel. This is the main casing of the engine, which consists of 4 L brackets and 2 base plates, which are on which the solenoids are mounted. The whole structure is made from mild steel. It is fixed to the base of it is fixed to the wooden base with the help of bolts and nuts. The machining operations performed for the manufacturing of this engine block are grinding, drilling, polishing, etc. and stuff. This is the piston rod. The piston is a member of the engine which first receives the mechanical output. A mild steel bolt has been used with slight modification which can be used as a piston. The threading of the screw has been cut in half and a drilling operation has been performed on the threading of the bolt, which can be used for connecting connecting rods. The piston moves up and down towards the solenoid, which convert the electrical energy into the mechanical energy. These are the bushes. Bushes are used on the base plate of the piston so that they are properly held at required angle, so that the piston may not move away while reciprocating during the reciprocating motion. This is the connecting rod. The connecting rod connects the end of the piston to the crank pin. The crank pin is an eccentric to the center of the crank web so that the motion gets converted to rotary type. It is made up of stainless steel. Here you can see that in the connecting rod, the two ends of the connecting rod have been drilled by a 5 mm drill, and polishing grinding has been done to the edges of the connecting rod. This connecting rod which we have used in our project is made up of a mild steel material. The next is a crankshaft. As you can see, this is the crankshaft. All the pistons are connected to the crankshaft due to the power developed by the pistons, and the crankshaft rotates. The one at the end of the wooden base is known as a flywheel, and the golden parts are called as the crank, and there is a connecting rod connected eccentrically to the diameter of the crank, and the connecting rods have been connected. This is the flywheel. It is obtained in the end of the power generated. Power is obtained at the flywheel. The flywheel is present at the end of the crankshaft. This is made up of stainless steel. The machining operations that have been performed in this are turning, facing, chamfering and drilling of the base. This is the crank web which acts as the crank of the crankshaft. This part of the engine converts the reciprocatory motion into rotary motion. This material is made up of stainless steel. The machining processes which have been done on the surface are facing, turning and drilling and counter boring. These are bearings. The bearings facilitate free rotation of crankshaft, thus reducing friction. These bearings are rolling contact type bearing. They're used for the free rotation of the crankshaft. These are the L brackets. These basically provide structures which bear loads and provide elevation. The L brackets which we have used are made of stainless steel 304 material and mild steel. These are held to the wooden base by bolting them to the base. The operations which have been performed for these L brackets are drilling and cutting using the lathe. This is the camshaft, which is made up of copper. The camshaft makes the circuit, breaks the circuit, thus providing power to the solenoids. When the solenoid wire comes in contact with the camshaft, power is generated for just a second and then it goes off, and this motion takes place. Gears are used to transmit the motion of crankshaft to camshaft. The gears used here are in the 1:2 ratio. We have changed the chain gears to the spur gears, and the ratio also has been reduced. These are grub screw. Grub screw is to use any assembly to hold in particular. The assembly being a hole and a shaft. The grub screw is made with an Allen key, screwed in with an Allen key, and also can be removed, which holds the materials together. Bolts, nuts and washers, these can be used anywhere in the engine to hold to fix themselves to the other parts of the engine or to the base. This is a rectifier. This rectifier is used to convert AC output of the dimmer to DC output. This is the dimmer which we have used in our project. This is used to vary output current and to the desired value. This dimmer is also used to increase the number of RPM and decrease the number of RPM of the engine that we want to make. This is an MCB, miniature, also known as miniature circuit breaker, which is used in the overall circuit as a safety measure so that the coils do not get burned, or in case of any short circuit that might lead due to the excess voltage or power supplied to the engine. That's it. This is all about our mini project, and we have yet a few other things to get back to. Thank you.